All right, welcome back. We left off right here. We were talking about sessions and storing other info in the cookie. So we're just going to keep rolling with that. There's going to be some awesome stuff, and I think I'll just give you a preview of that, what you're going to see today, and we'll see how quickly I mess this up. Well, there's that, and then there's this, and then there's this, and what version do I want to go with? This one. So that's 49, change directory 49. I'll do the big one. Change directory 49, and then 12. Lori.
Is it possible to ask a question about something that I ran into?
No, because if I don't have it pre-scripted, I can't. I got to think about it at home late at night before I give an answer.
You'll have this one.
No, go for it.
Okay, doing a couple presentations for functions, I ran into an error where when attempting to do two returns, the compiler was telling me that it did not like me using a second return done because it wanted it to be an error by default.
Uh-huh.
So, what did I do wrong?
I don't know, but do you have the code?
On my presentation work, I do. So, yeah,
So maybe you can put the code to GitHub and then send me a link to the code.
And I did put notes on it.
Yeah, great. And then I'll look at the code and
Okay.
I'll email it to Daniel and he'll give me the answer. I'll come back and I'll give it to you.
Default, I ran into an error as a second return.
There's no
No, that's
default to
fine.
error.
Yeah, and
Yeah.
you could do multiple returns. The only thing is, I don't know, maybe I don't know,
wrap
but
in parentheses if you got more than one return.
Yeah, you have to wrap
it in
parentheses.
I did, even when doing one just like yours.
yeah, just send us the code.
I posted it with notes and everything, but I thought maybe you know what I was talking about. Okay.
Not yet. All right, so where's this running? I gotta find my listen and serve. It's at 8080, and it's HTTPS, and localhost 8080. Whoa, cool fish! That's what you get to see today. There's a little fish, and I can look at my, my network, and I don't. Oh, I have to hit refresh. And so I could see like, hey, what's going on down there, and then resources. I could look at my cookies, and let me clear all those, and then hit refresh. Nothing, and so upload only when logged in. So you better log in, right? All right. Well, let me log in, and the password is a secret with capital S, I think, and with capital S, I think, or no, lowercase. Submit. So now I should be able to upload. Cool. Not the obvious redirect there back, remembering where you're wanting to go, but great. Now I could upload, and I could come over here and I could choose a new picture. So that means I should probably go find a picture that I want to upload, and we'll do that one. And then submit. Oh. Let me show you the other example. I know what I did wrong in this one. So I'm sticking that somewhere that I'm not looking. Yeah, that's a bummer. So we'll see the working example in just a second. I'll leave you with bated interest. That's what we're hopefully going to get to today. And so we left off a session. So we have listen and serve 9000 down here. And default serve mux, since that's nil. And then handle func, HTTP handle func. You're right. I think that's kind of cool. You can just call that right off of the HTTP package. There's a handle func, and you give it the path and then the function. And so then we're requesting the cookie and returning a cookie and error. And if the error is not nil, so there is an error. If there is an error, it means the cookie's not set, right? We ask for a cookie, and hey, there's no cookie, error. And so then we create a new UUID. And kind of this is where we left off on Thursday. Did I start record? I believe so. I believe so. I did. It did start record. And so we get that ID, and then we create a new cookie, and we call the value session ID, and then we say, hey, value, and we take that ID, and we turn it into a string, and we could add any other fields we want to it, so we could store all this stuff. And then all that gets encrypted using Gorilla Sessions, and it's all HMAC, so it's like whatever that stood for, hash, hashes it all and checks it and everything, hash made authentication code or something. So that's all, and then we set the cookie, and then we print the cookie to standard out. So then that's how you set a cookie. And
this one's not using the Gorilla Sessions.
This one is not using Gorilla Sessions. It's just using, thank you very much, using just a UUID. So that would not be secure. That could be cracked. So an example of storing user info in a cookie, no UUID here, so that's where we left off. It's pretty much the same thing, but this time no UUID, just storing user information. That's the same as the previous slide. And then just sort of looking at what happens when you run that, localhost 9000, and you can see the request, which comes from the client, goes to the server, and you can see it's passing session ID is equal to nothing, and then you have the response, which sends back a cookie, and it's equal to email, and then this was a form submission, so when the form was submitted, it included that query string parameter. Request method post, but that's not making sense. So usually that would be, here is, so form, submit, I didn't specify post, right? So did it default to get? Am I missing something?
Yeah, it is. It is on get.
Yeah, but is get the default? I guess that's my
Yes.
question right there.
Yeah.
Get's the default for a form?
Yes.
That's kind of nuts. It seems like it'd be post.
But then you've got stuff like Google where it's getting the search results.
And I think this is interesting, just the developer tools. So that's why I just keep showing this stuff, because it took me a while to become sort of familiar with, hey, where do I look for different stuff in here? So resources, I could see under there. I could see under cookies, I could see that. How many people feel comfortable with that? Like, this is like too redundant. I mean, I know this stuff already. How many people it's like, it's good to see. It's a good reminder. Okay, cool. So that's where you look in developer tools in Chrome. So wait, we didn't even talk about HMAC. All right, so hash-based message authentication code sessions, right? And the problem with the downside of cookies is that users can change the content. You can't trust the content. And we can protect against this with HMAC, which is hash-based message authentication code, right? So back here, we're doing a UUID. Great. I give the client a unique ID. I could store that unique ID, universal unique ID on my server and in the database. And then when I receive a cookie, I say, do you have a unique ID? Yes, I do. Here it is. I can then take that unique ID and look in the database and say, oh, okay, it's this record, which associates with this account. I can pull out all the user information, right? And then I could use that to display on pages or whatever. And you could answer it.
Hello, Matifus Joy.
I did not order a pizza. Who?
I'm sorry, this is a classroom. That's okay.
But if you're looking to deliver pizzas,
All right.
I thought it was an office.
There is one right next door.
did they have to pay their fees? We should have used that. That's a perfect opportunity for social engineering. We could totally hack them. What's your student ID and your password? I just need to check, make sure everything's in order here. What's your password? I'm sorry. That's not. I actually need a little more information. Your driver's license number, your credit card.
Recording still.
I know. That's the way you hack. That's the way most people get hacked. Social engineering. All right, Daniel, you're recording still. So this UUID, right? Somebody could if this is an HTTPS, somebody could be watching traffic on the network, right? And they could be using Wireshark to watch traffic on some big network, and then they could see this pass, and they could grab that UUID, create a cookie of their own with that UUID, and then they've just hijacked your account, right? So because you could change cookies as a user, then that's a security hole. And so we fixed that with hash-based message authentication code. And so just like when we were installing Go, we had that SHA-1 checksum. And when we ran it against what we downloaded, if it was different than what was on the Golang download page, just to show that to you. Right, so here's the SHA-1 checksum. So when I download this file and then run that on my computer, if I get a different result here, the file I received is not the file they intended. And so using that same logic, we could do this, where if the user, when a hash thing occurs, if the numbers are different, then it's it's the file's been tampered with. So that's hash-based message authentication code. So prevents cookie tampering, and by the way, Go has a fantastic crypto library. And you can read about HMAC by clicking that link right there. And so here's the crypto library in Go, a bunch of different stuff that you could create hashes with. Do you have any other way you want to say that? Or is there another way you say that in computer science? And then package HMAC is how you use HMAC. And this is crypto HMAC. And it takes so here's new, and it takes a function that returns a hash, right? And so here, HMAC new, and this right here, I guess, is a function that returns a hash. Just checking that. Yeah, new. And so there's the new hash. So this is how you would use that. So listen serve 9000, default serve mux, come up here, response writer, request, cookie, request cookie, get the cookie. If there's no cookie, we're going to create a cookie, and we'll give it a key and a value of name, session ID. And then if request.form value email is not empty, then we're going to set cookie.value to request form value email, and then get code cookie.value, get code. So this is the get code up here. And so this function here takes a string, and we're passing in the cookie value, which is email. And then with that, where does data get used? Data gets used right there. And so we create a new HMAC, and then we use the email right there, and we write that to the HMAC, and then we print out this value. So basically it takes email and turns it into this. So that's HMAC basically doing that thing like getting a SHA-1.
With the salt.
With the salt, with our key. So explain that. That just basically means that if somebody else was to do it with the email, they would need that special thing to get this value correct, right?
That's correct.
And then we have that, so we could take this and we could turn that back around and get the email back out of it,
I don't
right?
think so.
No? Okay, once it's done.
Hashes are usually one way.
Hashes are one way.
But that key is just something unique. You just come up with it on your own, bang on the keyboard with your hand flat if you want it to. It just has to be something that's different and no one's going to get. And it will kind of add that with the email before it does the hashing, in order to make sure that you can't just grab someone's email and turn it into the hash and get the unique code.
All right, so take a while to wrap your head around it. But basically it's the same thing as the SHA-1 checksum, which for whatever reason in my head is totally clear. When a cookie comes in on a request, we can verify it's been tampered with. This quickly gets complicated. We can use pre-built sessions library instead. So all this HMAC stuff, and I said this I think Monday, what's today? Thursday? Tuesday, I said it Tuesday, is just to kind of show you if you didn't already use a pre-built library, then this is all the difficult stuff you have to think about and do. But if you use a pre-built sessions library, like Gorilla Sessions, then you don't have to worry about it. So you can build it from the ground up if you want, cool, and you know all the internals, you know everything inside and out, all right? You're completely familiar with everything, but or you could just grab something somebody else built and at a certain point, like say, okay, that's good enough. So Gorilla Sessions is what Caleb recommended and what we used at summer boot camp, and the only thing that sort of like jumps up for me is like I feel like a desire to understand everything that my application's doing, but at a certain point, like I don't understand the standard library. I trust the standard library, right, more than I trust some third party. So like when it becomes third party, I start to be like, I don't know. There's part of me that just wants to be able to know how to do everything by myself. That's kind of hard for me, actually. I'm just talking about myself right now. Let's talk about Go. So. Overview, package Gorilla is a secure cookie encodes and decodes authenticated and optionally encrypted cookie values. It uses HMAC, right? And when encrypted, the content is also inaccessible to malicious eyes. So you could also have content in there, right? So, Gorilla Web Toolkit, you have to go get it to make it run. So you just go get it, and then it installs it into your workspace. That's how Go Get works, right? It's kind of like package management in Go. And let's start with an example that shows Sessions API in a nutshell. All right, so this is basically how you do it. And this is straight from Gorilla's website. So, let's see, we start a new session, sessions, new cookie store, slice of byte, something very secret, and we get a new store, so a new session store. And then down here in func my handler, get a session, we're ignoring the error resulted from decoding an existing session. Get always returns a session, even if empty. I don't know why they say they're ignoring it. I think they changed this, and then this comment's out of date. They forgot to change the comment, because it doesn't look like they're ignoring the error. But store.get, right? So then we get a new session, and then set some session values. So that's all you got to do to set the values. Session.values, key value, right? So it's like a map. And then session save, and we save our session before we return from our handler, right? A response from a handler. So that's creating a...
That save is confusing in that it's got the, it takes in the request and the response writer, but they've got them in reverse order from just about everywhere else. So keep an eye on that.
That's right. So we can now create sessions. We store session.values and get session.values. Being able to store email and user ID allows us to create a session for a user. So being able to store email or user ID allows us to create a session for a user. So listen and serve 9000, nil, create the store, and then here store.get, and so these arrows are pointing out basically the main steps here. Make the session, right, and then if we have a form submission and there's a value there, let's store email in our session, right, and then we're saving our session, and then we just write our response, and then that gets written back to the client. So when I run that, the request, I look in here, and I've got some sort of a form data going over, so form submission, and I can't see the type. That's kind of interesting. I'm interested in looking at that. I don't see if it's post or get up there, but I can tell right here that there's nothing in the URL. So right, if that was on my form submission, then it's going to be post. And then my request header, that's coming from the client to the server. It's the request. The client's asking for something. It's requesting something. And there's my cookie going over. All right, so this is the second request, I guess. And then here is my cookie being set, coming back in the response. So you can see that cookie is just jumbled characters, encrypted. And there's my cookie in Developer Tools. And exercises.
I believe Gorilla Sessions on their docs, down a bit further down, mentions they've got a memory leak bug.
Yeah, thank you. Keep going.
So you have to wrap your handlers with a Gorilla function in order for it to be able to properly free all its memory. It does it automatically if you're using the Gorilla router, but otherwise, yeah, right, like it shows there, you've got to make sure to clear the handler.
Yeah. All right, so here are a couple of. Do you like the fact that for the homework assignments I give you the answer? Is this material dense? Like on a scale, let me just see a show of hands. Like compared to your other classes at this level, like Comp Sci Top 100s or whatever, how you guys do the numbering over here, is this like easier than other classes? Raise your hand. The same as other classes, harder than other classes.
Not harder for me.
Denser?
But it is denser.
It's
It's a good
denser.
word, yeah.
Dude, there's like so much to know. Easier because I give you all the homework answers, and I'm like, I don't care. Turn your homework in or never. I don't care. Just copy that stuff, and you're done.
This class has got a lot more practical stuff, whereas the other classes have a lot more theory to them in addition.
So here's the answer to that one. HTTP application that tracks how many times the user accesses your web page with a cookie. These were really popular when the web was first created, about when you guys were born. So listen and serve 9000, request the cookie. If there's no cookie, create a cookie, set the value to 0, and then just get the cookie value, right? Cookie value, get the cookie value because there is a cookie. We got our cookie here. We just skipped that. There is a cookie. Or we created that and then we get the value anyhow. And then convert that into ASCII into int, and then add 1 to it, and then take that and turn it back into ASCII, right? And then set the cookie and then write it. Whoa, that's so cool. You guys get enough? You can look at it later. Here's your second one. Create an HTTP application that supports at least 2 endpoints, log in and log out. The login should accept a form and save a cookie with at least the username. And log out should clear the cookie. Awesome. And so here is not logged in and logged in. And if cookie value equals int to ASCII 0, right? So we're taking cookie value is going to be a string. And so if I take 0 and turn that into a string, and then say compare 0 as a string to the 0, if that's what's in my cookie value, then that means I'm not logged in. I'm using 0 not logged in, 1 logged in, right? And so not logged in, so I'm going to show a form to log in, HTML. And then here, if it's 1, right, cookie value is equal to 1, I am logged in, so then I'll just show a log out link, okay? And then over here, how's that work? I've got lines 9 through 41, so above that I'd have my imports. And then here I have all my HTML 42 through 80. And then here 81 through 85, I have the end of this. So this is all one big func main, which is, you should break that up. That's like too big. And then here, listen and serve 9000. Last thing I do is I write to my response HTML. So HTML is right there, my variable HTML, which is just the HTML. So which HTML am I writing? And then I get my cookie, right? Request cookie logged in. If there's no cookie, create a cookie and set the value to 0. You're not logged in, right? And then check the login. If request method equals post, right? Because here this is a method post right there. If that's post, then request form value password, right? So I'm getting password from right here, name. So I'm saying give me request form value, give me the value that was submitted in this form field, and set that equal to the variable password. And then if password is equal to secret, cool, that was what I was looking for. And I'm going to create the cookie and set the value to logged in or to 1. And then I don't know if that's right. Is that right? Am I kind of creating the cookie again? I just recreate it, right? And then that's the one I end up setting. Because if there's no cookie, but then that wouldn't run, this would run, this wouldn't run, and then what's down here? And if the path is log out, I'm going to, so there could be no cookie, and I create a cookie, and it's not post, and then I come down here, and the path wouldn't be log out, because log out, the cookie would already exist, all right?
Or they could have manually gone there. But either way, you'd just be overwriting the variable.
Just overwriting the variable, so that's fine. And so log out, set the value to 0 and max age to -1. The way max age works, Daniel explained on Tuesday, if it's greater than 1, then that's how long it lasts in seconds. If it's less than 0, then that's it means get rid of it immediately. And what's it mean if it's 0? Something I can't remember.
If it's 0, keep indefinitely.
Keep it definitely.
So you don't even need the value if you're deleting it, though.
Yeah. And then set the cookie. Let's see it work. So there's login, localhost 9000. First time I go there, I'm getting this login. There was no cookie, and then it serves up. Since I'm not logged in, it serves up this page right here, and sets logged in 0. And then my request going over, no cookie got sent over first time, right? I'm just coming there the first time, I don't have a cookie. And then sets a cookie in the response and sends that back. So that's where I got this. All right, I asked for this page, I didn't send over a cookie. When I asked for that page, I didn't have a cookie, so it said, hey, there's no cookie, I'm going to create a cookie. I'm going to set logged in and 0. And then I'll serve up the form to you. I skipped that because it wasn't a post. I skipped that because it wasn't logged out. And I send you a form. So you got the cookie and you got the form. And you can see that here. The server sent the cookie. And then I log in. So when I send in the credentials, my cookie goes over with it. My request, cookie goes over with it. My form data goes over with it. And that's why you can see this, right? Like, whenever you have somebody log in, you need it to be HTTPS. So that this can't be intercepted and looked at. And then the response that comes back from the server is, hey, you're now logged in, equal to 1. Because when I do that, do you have a cookie? Yes, you have a cookie. Is it post? It is post, right? So is password secret? Yes. Okay, I'm going to give you this cookie. Is it log out? No. All right, and then the one that came in, well, this is further down. So now you have a cookie with value 1. And so 1 is right here. So when that comes back, it's going to serve this back. So after I log in, right, it serves back that. And then I could click log out. I think that's what I'm doing here. Yeah. I click log out. I send over my cookie, my request. I'm logged in. It sends back, hey, you're no longer logged in, and max age is 0. So when I click log out, do you have a cookie? I do have a cookie, so I don't need to run that. Is this post? No. Is this /logout? Yes. Okay, I'm going to do this. And then you're logged out, so over here, I'm going to show you the form again. And you get the form again. I really like that example. I think that sort of captures it. How many people like that example? All right. The end. Next, we are going to look at TLS and HTTPS. So let's make it secure.